Hey, Talking About Math and History, and we are going to take a look at the factor theorem. So what we're going to do is look at 4 different theorems and explain how they can make factoring polynomials and finding the zeros a lot easier. But the factor theorem particularly is, if a remainder of a polynomial is 0, then the divisor is a factor, which works in both ways. So, if the remainder is 0, then it's a factor. But if it's a factor, then the remainder is 0, which means there's a converse. So what we're going to do is we're going to look at 3 different polynomials, evaluate them, and see what that actually means. And we're also going to experiment so we can see what that means. So, right over here is a problem. And the thing is, the problem is the p of x is 12x cubed plus 13x squared minus 28x plus 8. What we have to do is we have to insert 1, 4 into the x's right here and solve it out. So we're going to put 1 over 4 here, 1 over 4 here, and 1 over 4 here. We'll have to use a calculator to solve it all out. So, we have 1 over 4 to the power of 3. So we're going to write 0.25 to the power of 3. And that should multiply that to 12. So we have 0.1875. Something weird is going on. Let's see what happens with this one. So we have 0.25 squared, multiply that by 13, 0.8125. Now we have negative 28x and 1, 4. And we get negative 7. So we're going to put negative 7 right here plus 8. Now what we have to do is add the math together. So 0.1875 plus the 0.8125 is going to equal 1. 1 minus 7 plus 8. 1 minus 7 is negative 6. Plus 8 is positive 2. So when you put 1/4 into the equation right here, you get positive 2. So that is our first clue to the mystery. Now we have to find 2 more. So right over here is our second problem. And this one is a little bit less funky. What we have to do is we have f of x equals x to the power of 3 plus 7x to the power of 2 minus 6x minus 3. And we have to put 1 in for all of the x's. So 1 times 1 times 1, 1. 1 times 1, 1 times 7, 7. And we add the 2. 1 times negative 6 is negative 6. And minus that by 3. So we have 8 minus 6 is 2 plus 3 equals 1. So right over here is actually not 1, but negative 1. Just to recheck, 1 and 7 is 8, and this is negative 9. So it makes sense that that and that is going to equal negative 1. So that is our second clue. So the first clue, we had a positive 2. The second clue is negative 1. But what about the third clue? So right over here is the third clue. The h of x equals 6x to the power of 3 plus 13x to the power of 2 minus 4. And what we really have to do is insert that negative 2 in here and here. So here's what really has happened. Negative 2 to the power of 3 is negative 8. Negative 8 and 6 is going to bring you to negative 48. Negative 2 to the power of 2 is 4. And 13 times 4 is 52. And you add it because it's a positive. And then minus 4. But wait, this and this is going to bring you to positive 4. Negative 4 again, and that brings you down to 0. So, we have 3 different answers. The first one was positive 2. The second one was a negative 1. And the third one is 0. So what's the pattern? Well, what the pattern is right over here. So when we did 4x minus 1, but that translates when you do the zero product property to x equals 1 divided by 4, that is going to bring you to a remainder of 2. X minus 1 has a remainder of negative 1, and x plus 2, which is the opposite, is a remainder of 0. There is no remainder. So in reality, we inserted positive 1, and we inserted negative 2 as opposites before we put them into the equation. But wait, going back to the theorem right over here, if a remainder is 0, and the divisor is also a factor, which can be worked in both directions. So right over here, what is a perfect factor of the problem that we had? Is it number 1 right here? Is it number 2 right here? Or is it number 3 right here? Yeah, it's number 3. Since we have a remainder of 0, we can say that there are no remainders, and this right here, x plus 2, because it's the opposite of what we put in, is going to be a working factor that drives you to no remainder. So yeah, the factor theorem works because when you try to insert the x-intercept into it, it's going to help you understand what has a remainder that you can work off there. But in one condition, it has to be a linear line. What you put in for the x's cannot be anything else but linear. So that is how you understand the factor theorem. I hope this video has helped you understand the factor theorem. Thank you for watching How Can Analyze Math Industry. Like and subscribe.